Cosmic Revelations Unveiling the Unseen Universe with the James Webb Space Telescope, extended version. In the waning days of autumn 2021, the James Webb Space Telescope, JWST, was launched, marking a new epoch in humankind's cosmic exploration. However, the extraordinary discoveries it has made since then have left leading scientists in a state of awe, perplexity, and, at times, terror. The most powerful telescope humanity has ever built has captured images so extraordinary, so unexplainable that they have sparked a crisis in physics. From impossible galaxies to signs of life beyond Earth, JWST's latest discoveries have shattered the limits of known science and set the stage for a revolution in our understanding of the cosmos. The JWST's capabilities are truly unprecedented. With its 6.5-meter primary mirror and advanced instrumentation, the telescope can observe the universe in infrared light, allowing it to peer through the veil of dust and gas that obscures much of our cosmic neighborhood. Moreover, JWST's sensitivity and resolution are so extraordinary that it can detect the faint glow of the first galaxies that formed approximately 13.5 billion years ago, just a few 100 million years after the Big Bang. In July 2023, a team of astrophysicists analyzing deep field data from Webb identified 3 peculiar galaxies, unlike anything seen before. The light they emitted didn't match what we expect from typical star formation. Instead, it hinted at the existence of something entirely new: dark stars. These theoretical objects, powered not by nuclear fusion but by dark matter, could have formed in the early universe, growing to unimaginable sizes. Scientists now believe these dark stars might be the missing puzzle piece behind the abundance of black holes throughout the cosmos. The JWST's discovery of dark stars has far-reaching implications. If dark stars are real, they could rewrite the entire story of stellar evolution. We know that dark matter is one of the most mysterious substances in the universe, making up approximately 80% of its total mass. However, we still don't understand its nature, or how it interacts with other forms of matter. If dark stars are the result of dark matter collapsing under its own gravity, they could shed light on this enigma and help us better understand the fundamental forces that govern the universe. But the terrifying part is that we still don't understand dark matter. If dark stars are real, they could rewrite the entire story of stellar evolution. Webb was only getting started. In August 2023, the JWST turned its gaze toward a distant world named GJ1214b, a super-Earth orbiting a red dwarf 40 light-years away. Initially dismissed as too hot and cloud-covered to study, the JWST's infrared instruments pierced through the thick atmosphere. What they found stunned researchers. The planet not only had enormous clouds of water vapor, but regions of it were surprisingly habitable. Even more shocking was the discovery of methane, a compound often linked to biological activity. Some scientists now believe GJ1214b could be a water world, a planet entirely covered in oceans. Could life exist in such an alien environment? We may be closer to answering that question than ever before. However, the JWST's revelations were about to grow even stranger. In September 2023, while observing a distant quasar, the JWST detected a previously unknown chemical signature in the light it emitted, a molecule called phosphine. Phosphine is a rare, highly reactive compound that is typically produced by living organisms or extreme chemical reactions. Its discovery in a distant gas giant planet's atmosphere has led some scientists to speculate that life may exist there. Whether this is the case or not remains to be seen, But the fact that the JWST was able to detect this molecule from such a great distance is nothing short of extraordinary. But the JWST's discoveries were about to grow even more disturbing. In October 2023, while observing a galaxy at the far edge of the observable universe, the JWST detected polycyclic aromatic hydrocarbons, PAHs, organic molecules found in smoke, and also critical to life on Earth. These molecules were located in a galaxy so distant that their light has taken over 12 billion years to reach us. The JWST was only able to detect them thanks to the phenomenon of gravitational lensing, which magnified the galaxy's light. The implications are profound. If building blocks of life like these existed long before Earth was even formed, then life may not just be possible. It may be inevitable across the universe. However, the JWST's discoveries were about to grow even more disturbing. One of the JWST's greatest feats was recreating what once took Hubble 11 days in less than 24 hours. But what it revealed wasn't just beautiful, it was disturbing. The JWST's ultra-deep field showed galaxies so old, dense and well-formed that their existence threatens the very foundations of cosmology. These galaxies shouldn't be there. According to our current models, it should take billions of years for galaxies to reach that level of maturity. But there they are, massive galaxies with supermassive black holes, existing less than 600 million years after the Big Bang. Some of the black holes are 1,000 times more massive than the one in the center of our own Milky Way. It's as if the universe fast-forwarded through evolution. Among the JWST's breathtaking images lies one that sent a ripple of unease through the scientific community. It's a nearly symmetrical spiral galaxy, so perfect, so balanced in shape and color that it appears manufactured. But what shocked experts wasn't just the beauty of the image. It was the unexpected duplication of its spectral signature. In short, the JWST was capturing what seemed like a perfect mirror version of the same galaxy, slightly displaced in time and space. While gravitational lensing can create visual distortions, this was different. Both versions showed synchronized energy fluctuations, identical redshifts, and even matching movement in star clusters, like an echo of cosmic architecture. Some theorists now entertain the unthinkable. Are we witnessing an artifact of a multiverse? Could there be overlapping realities stitched into the fabric of space-time, only visible through instruments as precise as the JWST? If so, the telescope may not only be a window into the distant past, but into parallel versions of our own existence. The JWST's sensors, while primarily focused on the infrared spectrum, can also detect subtle frequency vibrations, essentially the sound signatures of space. In early 2024, while monitoring a dying star in the Carina Nebula, the JWST captured a rhythmic, low-frequency pattern, unlike any other stellar collapse. When converted into audible sound waves, the frequency resembled a repeating pulse, spaced with eerie precision. Astrophysicists expected chaotic, irregular patterns typical of dying stars, but this one was eerily ordered. Some compared it to a heartbeat, others to a coded transmission. The star had entered its death throes and seemed to be signaling as it faded into a black hole. Whether this is a naturally occurring cosmic rhythm or something more, deliberate remains open to speculation. But the most mind-bending discovery of all came in March 2024. While mapping distant galaxies in a sector near the constellation Fornax, astronomers noticed a temporal distortion, a phenomenon where redshift data from galaxies in the same region appeared to move backward in time. That's not just odd. It's impossible under the standard model of cosmology. The redshift should increase with distance, representing older light. But in this pocket of space, galaxies seem to reverse age, their light signatures growing younger the farther out they are. The implications? Either our entire understanding of space-time is flawed, or there's an error in the cosmic fabric, like a scratch on a record that replays the same note out of order. Some physicists call it a time fold. Others believe it could be evidence of a simulation glitch. One thing is certain, the JWST may have just proven that time is not as linear or reliable as we once believed, and in doing so it has left scientists staring not at answers, but at a void of questions too big to comprehend. So here we are, on the edge of understanding, staring into a cosmos that no longer obeys the rules we once trusted. The JWST was meant to confirm our theories, to clarify the origins of the universe, to shed light on the unknown. Instead, it has torn apart the script of modern science. From dark stars born in the shadows of creation, to galaxies that grew too fast. From echoes of parallel realities to the final heartbeat of dying suns. The JWST isn't just revealing the universe, it's redefining it. And as if that weren't enough, artificial intelligence has now joined the quest, flagging anomalies we can't explain, patterns we can't classify, and gravitational ghosts that haunt the dark between galaxies. The telescope was built to see farther than we've ever seen, but what it found may be farther than we're ready to believe. If the past few months have taught us anything, it's that space is not silent, not simple, and certainly not solved. What we once called laws may now be guidelines. What we thought was the beginning may only be a checkpoint. And the scariest part, we're just scratching the surface, because if this is what the JWST has discovered in its first steps into the unknown, what comes next could truly break reality. So what do you think? Has the telescope truly broken science? Or has it finally set it free? Let us know in the comments, and don't forget to subscribe if you want to stay on this journey across the edge of the universe, because the next signal might just rewrite your world.